Hi, everybody. Hope you're having an awesome day. Thanks for watching. We are continuing on our factoring quest during chapter 2 here. We're on for 2.7 today, factoring special products. I will let you go ahead and do the video, or not the video, the starter. Pause the video to do the starter. And then when you're done, unpause and we'll continue on. So number one, the first kind of special product that we'll factor today is called the difference of squares, difference of two squares. You really don't have to do anything different than we've been doing, just use the same techniques that we've been using in this chapter. One thing that looks a little bit different about these differences of squares is that they're going to be binomials. The last few lessons we've factored trinomials, so one tip is just remember, if it's a binomial, that means it's really missing a term. This one's missing the middle term. So if you want to, you can put in a plus 0x right there. So x squared plus 0x minus 25. And then we can factor that pretty easily. So we know it's got to be an x, and remember our process here, what two numbers multiply to be negative 25 and add to be 0. I think it'll be a plus 5 and a minus 5. So that's how it factors. Second example, 4x squared minus 9, if we want to factor that. Remember, it's really like there's a plus 0x here in the middle. This is the harder kind of trinomial factoring because there's a number here in front of the x squared. We'll have to use the x method on this one, or guess and check if you're a fan of guess and check. In the top part of the x goes the 4 times the negative 9. In the bottom part of the x goes the 0. So what two things multiply to be negative 36 and add to be 0? I think it's 6 and negative 6. And then remember, you divide both of those by 4, whatever that leading coefficient is. Simplify the fractions if you can. And these are your factors in disguise. Remember, the bottom number goes out front. So it'll be 2x plus 3 and 2x minus 3. That's how that one ends up factoring. Just one more here. 2x squared minus 72. Something that's different in this than in the other two examples is that this one has a common denominator that you can pull out. I could pull out 2 from both of those terms, and I'd just be left with x squared minus 36. So if there's ever a common factor that you can pull out, that's always actually the first thing you should look for. Remember, there's really an invisible plus 0x there in the middle. I think this one will be x plus 6 and x minus 6. Don't forget that 2 we factored out. That's still a part of your answer. At this point, you've probably noticed a pattern going on. The numbers are all the same as each other in the two sets of parentheses, just one is a plus and one is a minus. So if you learn to notice that pattern, you can save some steps and really just factor it in your head, like the square root of x squared is x. So I know I'm going to have an x here and an x there. The square root of 25 is 5. So I know I'm going to have a 5 there and a 5 there. One's got to be a plus, one's got to be a minus. The square root of 4x squared is 2x. So boom, 2x, 2x. The square root of 9 is 3. So plus 3 minus 3. On that note, number 2, once you start getting the hang of it, you might just be able to recognize the pattern that's happening and save yourself some time. So let's try to factor these just using the difference of squares pattern. Square root of x squared is x. Square root of 36 is 6. One's got to be a plus, one's got to be a minus. And remember, if you're ever doubtful, you could always check yourself by foiling it out, making sure you really got back to the original expression there. Using that pattern, the difference of squares pattern, you can even factor some stuff that maybe we wouldn't have liked to factor before. This is kind of out of order, but it still works because the square root of 100 is 10. One's got to be a plus, one's got to be a minus. The square root of m squared is m. So even though this isn't how we've normally seen these binomials, we can still factor them if they're differences of squares. Here's another one, 9n squared minus 16. The square root of 9n squared is 3n. The square root of 16 is 4. One's got to be a plus, one's got to be a minus. So these are really quick once you get the hang of it. Let's see, I think this one will be 4h and 7 and 7. One's got to be a plus, one's got to be a minus. Up until now, we haven't ever been able to factor anything. I don't think we've even seen anything with an x and a y in it, but using our difference of squares patterns, the square root of 16x squared is 4x. The square root of 169y squared is 13y. One's got to be a plus, one's got to be a minus. So that difference of squares pattern is pretty handy when you're trying to factor things. I just noticed a typo. That is not example 2, that's example 5. Pretty handy pattern there. Okay, so number 3. The other kind of special polynomials that we will factor today are called perfect square polynomials. Again, not much different than what we've done so far this chapter. Practice a bunch of them. Here's one, m squared minus 2m plus 1. Well, that doesn't look very special. Let me show you why they call it special here in a second. We know it's got to be m and m. What two numbers multiply to be positive 1 and add to be negative 2? Well, I think it's minus 1, minus 1. Because these are the same, you could actually write your answer a little shorter. You could write m minus 1 squared, because we're just multiplying m minus 1 by m minus 1. That's why it's called a perfect square trinomial, is because it'll come out to have the exact same factors, which you can just write it as something squared. Here's another one, d squared minus 10d plus 25. What two numbers multiply to be positive 25 and add to be negative 10? Well, it's negative 5 and negative 5. And remember at this point, it's a good idea just to check yourself. Does negative 5 times negative 5 really multiply to be 25? Yes. Do they really add up to be negative 10? Yes. And kind of the fancy way of putting your answer is d minus 5 squared. And you can get things that are a little bit tougher. This one we'll have to use the x method on. 25 times 4 is 100. What are two numbers that multiply to be 100, add to be 20? Believe it's 10 and 10 divided by 25. Simplify. So that'll be what, 2 over 5 it looks like. And those are our factors in disguise. So it'll be 5n plus 2, and the other one will be the same, which is what we were going for because they are perfect square trinomials. No, I'm pretty confident. I didn't put any examples like this, but if by chance you saw an equals 0 here, I'm confident you'd remember what to do. You'd set each factor equal to 0 and then solve it out. There are a couple on the assignment where you have to set them equal to 0 and solve them out. But that's really it for 2.7, just those two kinds of special polynomials, differences of squares and perfect squares. So as always, thanks for watching. Hope to see you back in class soon. You are awesome.